So in the previous tutorial video, we show you the basic syntax for the while loop. I also try to trace the program using different approaches. We use a flowchart. As you can see, we use flowchart. We use a tabular form. Also, we show you on the Eclipse how to use debugger and breakpoints to trace the while loop. It's really important for you to understand every one of them before you try to continue with more advanced examples. So now for this video, we're going to show you how we can integrate user inputs into while loop and make some interesting application, especially how we can say, now we're going to let a user to actually enter some, let's say, integer variable. Let's say we're going to let them enter, let's say 3 different integer, let's say, and they want to calculate its average. But let's say every integer must be strictly positive. So now, if the user has to try to enter anything that's not strictly positive, we can give them a second chance or a third chance, or as long as it will take for them to actually enter a positive number. That's kind of the error handling we can do using while loop. Okay, let's see how exactly we can do it. Okay, so hopefully from there, you can try to be more creative to really solve your problems for the lab exercises or in the lab tests maybe. Okay, let's now create a new Java class, and as usual, let's do the Java program first and use the as a console application, understand the behavior first, and then we'll trace it using the different approaches. Okay, so now right click on the projects and then say new, and then Java class, and then let's say while loop app. While loop app. Okay, so that means we're gonna have some user input, very easy user input, just as an exercise. Okay, put a main method here, and then we'll say finish. Okay, that's what we get. We're gonna get something very similar to what we did before. If you recall what we did for the for loop app over there, where we simply just get we try to calculate the average of 5 integer values, and then we try to do that using a for loop, right? So now let's make the problem even simpler. Let's say we only want the user to enter, let's say 2 integers, let's say 2, but we can still really use a while loop, doesn't really matter. Let's say 2 integers, but now for every integer, it must be strictly positive, which means as long as the user is not really entering the valid integer being strictly positive, we have to keep prompting them, giving them chances to really fix their value. Okay, that's something we want to do. Okay, so now let's see this. Okay, so now let me just say this over here. Prompt the user for 2 strictly positive integers, and okay, and let me fix the typo. And once you get 2 positive integers, and calculate their average. Okay, and then so error handling is really important. So now we're going to do something that we couldn't we could not have done in the previous exercises. Okay, error handling. So now for each integer, as long as the user cannot enter a value strictly larger than 0, we have to keep prompting the user for an integer, which means we're gonna keep prompting it until they give us some valid integer being strictly positive. Okay, so now let me just fix the typo here. Okay, let's now try to do it. Okay, so now because there will be 2 integers, that means we based on what we learned from the for loop app, so we just need 2 iterations, 2. So the number will be 2. Okay, so now what we can do is, let's try this. Okay, we can say, let's try the while loop. So we can do, let's say first of all, since we're gonna use user input, let's say scanner input is new, scanner input system.in, and then we're gonna say input.close over here. Okay, and then we're going to declare our loop counter here, which is I. Integer I is simply equal to 1, let's say, and while I, as we learned from the previous video, let's say if we want 2 iterations, while I is less than or equal to 2, and then we're going to do this and always put at the end I++. Okay, make sure you do that, because if you didn't do this, I would never be able to the i's value will never be able to make this false, which means we keep staying here, which means we never get a chance to exit from the loop. Okay, that's not good. Okay, so now for each one of them, we're going to prompt the user for some integer. Let's just do that first, and then I'll show you. Okay, and then we can say system.out.println. Okay, we can say enter integer. Okay, as before, we can say integer 1, integer 2. And then we're going to say colon here. Okay, there's a prompt. And then let's say here, we also got a local variable here. Okay, we can say integer x is input.next int. Okay, and then we can also have some total value, right? As we did before, integer total, and we can keep accumulating to total. Okay, initially just 0. And then we can say total plus equal x, right? Okay, so now when we exit from the loop, so outside the loop, so we know that total has been accumulated to the 2 strictly positive integers. So now what we can do is we can say total. Okay, actually we can say double. Average is, okay, we can do a cast. We can either say cast the total into a double. We can say, or we can simply say total divided by 2.0 because we got 2 integer, right? I'm just showing you 2 different ways of doing things. Okay, and then finally we can say system.out.println. Okay, over here I can say average is, and then the average. Let's try to run this program here and see how it might go wrong. Okay, if you're lucky, if the user simply give you 2 strictly positive numbers, you will certainly calculate average accordingly. However, if they actually give you something that's not strictly positive, then at the moment there's no way to really warn the user about it and let them re-enter the the integer again. Let's try that. I will illustrate what I meant. So right click on while loop app and say run as Java application. Okay, now integer 1, let's say 3, integer 2, let's say 4, and then you got 3.5. Okay, that's good. That's a very good run because the user is behaving well. They enter 2 integers that are strictly positive. Okay, so now if I say over here, you know what, let me just change the program a little bit, just make it even more explicit for you. Okay, let me just stop it. Okay, so enter a positive integer. Okay, that means every time you want to enter a positive integer. Okay, okay, enter positive integer 1. If I say 3, enter positive integer 2, I say 4. Okay, 3.5. That's good. What if the following run? If I say run again, if I say minus 4, it doesn't stop me. Okay, it doesn't at least prompt me again to say, oh, the first integer is actually not strictly positive. You better try again. And enter positive integer. I say minus 9. Well, average is minus 6.5. You know, it's correct average, but remember we said that we must make sure for every integer that the user has to be entering strictly positive integer. If that's not strictly positive, we have to keep prompting the user to actually enter, to say, if they enter minus 4, we'll say, oh, I'm sorry, minus 4 is not positive. Try again for integer 1. If they enter minus 9, it will say, oh, I'm sorry, this is not positive. You got to try again, right? That's kind of the stuff we like to do for very useful console application. Let's try that right away. Okay, so basically, I'm gonna what I would do is we have the so-called compound statements, which means within a while loop, okay, as part of the body for the while loop, I can have another while loop, okay, which means for that particular while loop, inside this particular while loop here, is going to try to do some error checking for us. Okay, let's see how we can do it. Okay, so now I'm gonna make it very simple for you. So now what I would do is like this. Okay, we simply got something like this. So we simply have, okay, like this. Let's say if, let's say we simply read the x from user, and then we simply say if x is larger than 0, that's the valid input condition we like, right? But we're going to say if it is not the case that x is larger than 0, it is not the case that it is valid, right? We talked about negation previously in the class. We're trying to say that if it is not the case that the user enter input is not larger than 0, we're gonna prompt it again. Okay, and then what we would say is we're gonna say system.out.println. Okay, we'll say error. Okay, we can say that x plus is not larger than 0. Okay, and then we can say system.out.println, and we can say try again. Try again. And then, okay, so try again. So you can simply try again. So now we can simply reassign x to be another input on x in. Right? That's exactly what we're doing. So now notice one thing here. You can see that we declare the variable x outside the scope for this particular if branch. So you can think about the if branch over here. The scope for the body of the if branch over here is a subscope of this particular x over here. So it can be used. So we can definitely use x inside this particular if. Okay? That's why we can do that. Okay, so now we got this. We say if it is not the case, actually what we want to do is, rather than if, what I meant to say is while. It's even better, because if you only say if, it's only going to tell, well, if you only say if, in this case, it's only, okay, let's say we enter -4. Okay, let's say we do that. If we enter -4, so -4 larger than 0 will just be false, and then not false will give us true. That means it's an error. So it's an error, -4 is not larger than 0, try again, and then we let the user try again. What if they enter -3 this time? If they simply say -3, it's just going to go into this line of code anyway, because if statement is just one pass. It doesn't really let you check the state condition again. So that's why while loop will be the way to go. Okay, that's why we did a while loop here. Okay, so now let's just try that and see how it works and why it works, and I'm gonna trace it. So now let's execute the program again. Enter a positive integer 1, -4, error, -4 is not larger than 0, try again. If I say -3, error, -3 is not larger than 0, try again, right? You can try as many times as you like. As long as the user didn't enter a number that's strictly positive, they always have to try again until over here they enter something that's strictly positive, so that something that's strictly positive will make sure this part over here is true, and then not true will give me false. So which means I'm going to exit from this particular loop, and then we'll go ahead and try to accumulate the total, right? So let's try that. Try again. If I say 4 over here, now they will say enter a positive integer 2, right? Now for the second one. Now I can do the similar error handling for the second one. For the second one, I can say -9. They will say -9 is not strictly positive. Try again. -10, not strictly positive. Try again. -23. Okay, even I can try 0, it's also not positive, right? You can see the user just had to keep trying, but it's a very robust program over here. We want to make sure every integer we read from the user before we try to calculate average, every integer must be strictly positive, right? So now let's say so 4 and 3. Okay, let's say 3 over here. Now they will say average is 3.5, which means it's the 3 over here and the 4 over here that we actually try to store into for average. Okay, so now this is the program I have. I want to show you. You can see it's actually very still not very complicated, but it's fairly nice to actually show you the logic over here. So the outer while loop over here controls how many times, how many integers you're going to prompt the user to enter. In this case, 2 integers. But as part of the body for each iteration, we also got another nested while loop. And this while loop over here, okay, let me just write it down. This outer while loop controls the number of times that the user will be prompted for an integer. And now currently as we set up, because we say initially I is 0, I is 1, and then as long as I is less than or equal to 2, and then each time we just increment I by 1. So that means that make sure we got exactly 2 iterations to be executed for this particular outer loop, right? And now this particular inner loop, okay, this inner while loop, okay, let me fix the typo here. this inner while loop controls the, I would say, indefinite, because you can see as long as the user enters some number that is not larger than 0, then we're going to keep prompting the user. If the user simply just cannot enter positive number, then we're just going to prompt them for an infinite number of times potentially, but that's okay. Hopefully they will learn, right? Controls the indefinite number of times for the user to try, for the user to attempt entering a number that is strictly positive, right? Okay, that's kind of the idea for the inner loop. So you can see the outer loop and the inner loop, even though they're both while loop, but they are there for different purposes. And it's important that the inner loop is nested within this while loop. Okay, that's again some creative pattern I'm showing to you over here, so you can try to be creative, you know, as long as it can suit your need for your lab exercises or later on the lab tests. Okay, it will take some practice, but at least I can show you some common pattern over here. That's one of them. Okay, so now let's see over here. What I will do is I'm gonna copy the code and then show you on iPad, and then we'll run debugger eventually. Okay, so now what I will do is, let's say I'm gonna copy this fragment of code and then we're gonna trace it together. Okay, let's say only this part over here. Okay, so now let's move on to iPad. So now I'm gonna simply annotate the code fragment directly to show you how the code will behave. Okay. Okay, let's say that's the fragment of code we have over here. Okay, let me just make it a little bit bigger. Okay, just like that. Okay, so now let's see exactly what's gonna happen. And then at the same time, let's say we also got our console over here, right? So let's say this is a console over here. Okay, imagine that this is the console. Okay, that's a console over here. Okay, so now let's see what's going to happen. And then I'm also going to show you the variables over here. We're also going to trace it, right? So now for line number 1, so now when we first execute the program, we're going to initialize I over here to be 1. So that means we have a box for I, which is 1. Of course, you can, when you run a debugger, you can see from the variables panel or the expressions. And also, total is going to be 0. Okay, total is going to be 0. Okay, that's these two lines. And then for the very first time, we say while, okay, right? There's an outer loop. And then what we're going to do is, we're going to say while I is less than or equal to 2. That means we're going to evaluate 1 less than or equal to 2 is going to give me true. Okay, that means we're going to execute the body of the loop line by line, the outer loop line by line, yes. Okay, and then we're going to execute this particular line over here. So it would say enter a positive integer, and then in this case I would just be 1. Okay, I'll just write it on the console. Okay, so now they would say enter. Okay, I'll make it a little bit briefer. Okay, enter integer 1. Okay, that's what the console would say. And then the user can actually now decide what to enter. Let's say the user enters something that's not positive. Let's trigger some error over here. Okay, so now what the user would do, let's use green. Let's say the user simply enter -3. Okay, that means input the next int is going to be -3. And then x is going to store -3 in this case, right? So now we're going to evaluate the inner while loop over here. And then how do we evaluate this? That means we got not the case, and then x at the moment is -3. -3 larger than 0 over here. So it is not the case that -3 is larger than 0. Well, let's think about it. -3 larger than 0 is simply false, right? Because -3 is negative. It's not strictly positive. So now, not false will give me true. So that means the whole evaluation over here is, okay, let me just circle it better. The whole evaluation over here is just going to be true. That means we're going to execute this line of code over here. We'll say error. Oh, I just found the I just found a typo over here. Let me just do that quickly. Okay, so we're going to say error, and then we say x, in this case, is -3. It's not larger than 0, right? So that's what's going to be from the console. They will simply say error. They will say -3 is not larger than 0, okay? And then after that, we're going to go on to the next line, and then try again. Oops. And then they will say try again. Okay, and then we're going to prompt the user for another input over here. Let's say the user didn't learn. They enter just another negative number. Okay, well, let's see what's going to happen. Let me use another color. Let's say pink. And now this time, the user is going to enter, let's say, -4. Okay, so that means -4 over here is going to be read from the keyboard. Okay, and then so that means x is going to be reassigned to -4. Okay. So now over here, and then you can think about it like this. Okay, something I forgot to draw. When we actually first try to initialize x over here, you can see x over here is simply just -3, right? Initially, right? That's what was seen from the previous one. And now x is reassigned to -4. Okay, just keep track. Okay, so -4. So that means we have to go back to the header of the while loop over here and then evaluate. So what do we evaluate? So now x will be just -4. So we're trying to evaluate -4 larger than 0, and it is not the case, right? Is that true or false? Well, -4 larger than 0 will give us false. It's negative, right? And then apply the exclamation mark, the negation will give us true. So that means overall, this will still be just true, okay? Still be true. So that means we have to still execute this line over here. So we're going to say error, and then in this case, x will just be -4. It's not larger than 0. Okay, let's just try that. So we'll still say error, and now in this case, -4. -4 is not larger than 0, and then we'll say try again. I'll expand the console in a moment. Okay, and then when we say try again, that's basically this line over here, right? So after that, we're going to prompt the user for one more time. Okay, let's say this time user does enter something that's strictly positive. Let's say this time the user enter, let's say +5. Okay, 5. And then let me just expand the console a little bit over here. Okay. Okay, let me just expand it all the way until the end, so we got enough space for the rest of the run. Okay, can I just make it a little bit better over here? Okay, that's good enough. Okay, let's say the user enters enter 5 over here, so that means x will be reassigned. So that means over here we got 5 from the user, and x is going to be reassigned to 5. That means rather than -4, it's going to be 5 over here, right? And then at the end of the while loop, we're going to go back to and execute the header of the while loop again. So now what do we evaluate? It's going to be 5 larger than 0, and then we have the exclamation mark over there for this expression, right? You can see exclamation mark, and x in this case is simply 5. Okay, so now what do we have? 5 larger than 0 is going to be true, and not true is going to give you false. Okay, that means this evaluation over here is going to give you false. And what does that mean? That means we bypass this particular while loop. So that means we'll go all the way, we'll skip that and go all the way to here. Okay, hopefully you can see that. So that means for integer number 1, we are safe. It's simply just 5. And then we have total plus equal, which is as if total plus total is assigned to total plus x. In this case, x is 5 plus total, it will just be 0 plus 5, it will just be 5 after this line. And then we're going to increment I over here, I++, so that means I from 1 to 2. Okay, and then after this, we're going to go back to the beginning of the while loop over here, and then we're going to evaluate this expression again. So now in this case, we're going to evaluate 2 less than or equal to 2, which is going to be true. That means we still have to evaluate the body of the outer while loop once more. Okay, so now let me just do it orange. Okay, So now let's say for the second time, the user can simply enter some positive integer for the first time. But to see how the inner loop actually works, I'll leave it to you, right? It's we already explained. So now let's say over here, we try to execute the first line over here. So now the user is going to enter some number over here, right? So now let's just prompt the user. So we would say enter. Oh, when you say enter over here, you can see that here the I value is currently 2. Okay, so now we're going to say over here enter integer 2. Okay, let's say the user is trying to enter something, right? They can enter anything they like. You know what? I really want to show you for completeness. Let's say the first time they enter something that's negative. Let's say they enter simply -6. Okay, if they enter -6, that means X is going to store -6, right? Right? That's going to be -6. So rather than here, it's going to be -6 over here. So -6, and then so we're going to evaluate this condition again. Okay, let me just write it down. It's going to be not the case -6 larger than 0, right? Exactly this condition over here, right? It's a little bit messy over here, but it's going to be this condition we are trying to evaluate, not the case X larger than 0. So what do we have? -6 larger than 0 is false. Applying negation, we're going to get true. So that means for this particular evaluation over here, we get true. Okay, so if we get true, that means we're going to evaluate this line over here in the body of the loop, right? So we're going to say error, and then in this case, you can see that X is simply just -6. So error -6 is not larger than 0, and then they will say try again. Okay, you will execute this line to say try again. Try again. Okay, and then let's try again. Let's say this time the user really entered the right thing. Let's say they enter 4. Okay, so now I'm gonna do what about red? Okay, so let's say this time they're going to enter another value over here. Okay, let's say they're going to enter 4. Okay, 4 over here. So that means X is going to store 4. So rather than -6, it's going to be 4, right? We can keep overriding the variable. That's really important for you to keep track. Okay, so now after this, we're going to go back to the beginning of the while loop over here. So what do we evaluate? Basically, we're going to evaluate not the case 4 larger than 0, right? For this particular expression over here, right? 4 larger than 0 is true. And then, not the case it is true, it will give us false. So that means for this guy here, it's now false. That means the state condition is false, we bypass the loop. Okay, and then, so after this, we're just going to execute this line over here. Total plus equal X. X is 4, so total at the moment is 5 from the previous accumulation. So 5 plus 4 will be 9. So that means total will be accumulated to 9. Okay, so after this, total will just be 9, and the I++ is going to increment from 2 to 3. So now I will become 3, right? I will now become 3. And now we go, after this line, we go back to the very beginning of the outer loop. We're going to evaluate this state condition again. So what do we have? So you got, basically I is now 3. 3 less than or equal to 2 is going to give us false for sure. So that means at the moment it's going to be just false. All right. So that means we're going to bypass all the entire body of the while loop. We're going to bypass, right? Just bypass that. And then we're just going to now execute this particular line of code, right? Average is going to be total. In this case, is just going to be 9. So 9 divided by 2.0 is going to be 4.5 with precision. So that means 4.5 will be stored into as the average, right? That's why you will get average 4.5. Okay, so that's exactly how you will see. Okay, and then of course, eventually you will see there's another print line over here. So that will be average is 4.5. Okay, hopefully you can see that I try to really show you that. You can see that for the outer loop, is exactly enter integer 1 and also integer 2. Okay, this is the outer loop. is controlling that we do exactly two times for you to enter the integer, right? However, for each one of them, you also have an inner loop over there, which is over here. This is the inner loop, which will make sure as long as you actually enter something that is not valid, you just keep prompting the user for as many times if it is necessary until the user enters something that's strictly positive, right? So this is the inner loop. Okay, hopefully you can see that. And again, this part over here is simply outside the outer loop. Okay, that's what just compute the final answer for the average. Okay, hopefully you can see the idea here. Now, finally, I would like to show you how you can run this in the debugger and see that by yourself. That can be a very valuable debugging technique you can pick up for your future lab exercises. Okay, because for the future lab exercises, you might have to run loop that's much more complicated than this. And how can you find issues in your loop? Debugger. That's the answer. So what I would do is I'm going to put my breakpoint over here, basically line number 1, right before I try to initialize I to be 1. Okay, let's run exactly what I have set up over here, so you see exactly what's going on. Okay, you will see the complete correspondence. Okay, so now I'm gonna right click on this while loop app, and then I'll say debug as Java application. Okay, so now I'm switched to the debug perspective. Okay, you can see the debug on the top right corner. Okay, so now I'm at the point right before I try to initialize I to be 1, so I does not exist just yet. If I go to expressions over here, let's delete all the previous one. Okay, let me just right click and say remove all. Okay, just clean up from the previous debugging session. Okay, so now let's have a look. So now if I say step over here, okay, make sure you do step over rather than step into. Step into would not make sense until we talk about methods later. If you say step over, you can see for the variables I is now 1. Okay, and then if you say step over again, you will see total over here is 0. Okay, so far so good. So now how does this outer loop state condition here evaluate into? So if I can simply say what's the value for I, and what's the value for I less than or equal to 2. Okay, at the moment, because 1 less than or equal to 2 is just going to be true. That means we're going to go into the loop, right? If you say step over, yes. And then if you say step over again, we're going to say enter a positive integer 1. 1 over here, simply because if you look at the I value over, it's simply 1. Okay? Okay, hopefully it's getting more and more comfortable for you to see the debugger. Okay, let's say now, let's say we do exactly what we did. So let's say -3. Okay, if I enter -3 over here, enter, and then I can say step over. You can see now, if you move your mouse over, x is now -3. You can also see that from here, x is -3. So now, how do we evaluate this particular state condition? I'm gonna break it down for you, okay? So now, you can go to expressions over here. First of all, let's see what x is. X is -3. And I can say x larger than 0 will be false, apparently. And what about not the case, x is larger than 0? Over here, it's going to be true. So this is the ultimate expression we have to evaluate in order to decide whether we want to go into this particular inner loop. Okay, in this case, because not the case, x larger than 0 is simply true, that means if you say step over, we're going to step into the loop, right? Okay, hopefully you can see that. So now that means we're going to say error, and what's x? If you move your mouse over, it's simply -3. If you say step over, we're going to say error -3 is not larger than 0. Good. And then if you say step over again, you're going to say try again. Okay. If you say, so now we are expecting the user to enter just another integer, right? Let's do exactly what we did. Let's say -4. If I simply enter -4 over here, enter, and then I say step over, you can see now, if you go to variables, x is now -4, right? Used to be -3, but it's now -4. You can see from the expressions over here, x is simply -4. -4 larger than 0 will give you simply false. And not the case, x larger than 0 will negate false, which will be true. So that means this expression over here still evaluated true. That means the user's input is still not satisfactory. So now that means if the state condition for the while loop is simply just true, then we gotta go into the loop once more, right? If I say step over, we're gonna go do it again. So now we'll actually print out this line. We're going to say error, and what's x in this case? It would be -4, right? Remember -4 over here, okay? And then we can say step over, and then it's going to print out error -4 is not larger than 0, okay? And then if we execute line number 30, step over, it's going to say try again. So now let's say we really enter something that's valid. Let's say 5 over here, okay? If I enter 5 over here, enter, and then I say step over again, you can see now, go back to expressions over here. Let's see the variables first. You can see variables x has been changed to 5. So now if you can see expressions over here, x is 5, and 5 larger than 0 is true, and not the case, x larger than 0 will be false, which means this particular state condition here, 5 larger than 0 is true, not true will give you false. So that means we're going to bypass the while loop here, right, for the first integer. If I say step over again, you can see it bypassed everything over here inside the while loop and go to here. So now what we will do is we're going to increment total by x value. If you look at what total is at the moment 0, we're going to increment 5 into it because x is simply 5. Okay, let's see what's going to happen. If you say step over, you can see total has become simply just 5, right? You can see yellow highlight means that's the only variable that's been changed by executing that line. And then when we say I++, at the moment I is simply just 1, meaning that we're still dealing with the first integer. But now if we say step over again, it's going to change the value for I. Okay, so now I has become 2, from 1 to 2. Okay, so now we go back to line number 20, which is to evaluate the state condition for the outer loop again, to see if we want to execute one more time for the second integer. But actually we are going to, because we need to prompt 2 integers rather than just 1. So what we will see is if you go back to expressions over here, you can see the I value at the moment is simply just 2, and 2 less than or equal to 2 is going to be true, right? So if you say step over, of course we'll go into the loop and we'll simply say enter a positive integer. What's I at the moment? It's simply 2, right, rather than 1. If you say step over, it's going to say enter a positive integer 2 over here. Okay, let's enter that. Okay, what we set it up was, let's say the second integer will just make a mistake at the first time. Let's say -6. Okay, let's say -6. Okay, and then I would say step over. You can see now in the variables, x is simply just -6 over here, right? You can see -6. And then we go to the expressions panel over here. X is -6 over here. And then -6 larger than 0 will be false. And then negating false will be true. That means this particular state condition will be true. That means there's an error for the second integer. So if you say step over here, we'll say error. And what's x? In this case, -6, right? If you move your mouse over. Okay, so we say step over. We're going to say error -6 is simply not larger than 0. Larger than 0. You can see so far we got exactly the error, the tracing that we had manually in the iPad, right? Well, I really want you to learn both. Okay, so now it would say it is not. If you try to execute line number 30 by saying step over, it would say try again. Okay, so far so good. So now let's say we try the second time for the second integer. Let's say we enter 4, okay, as we set up previously. And now if I simply just type in 4 over here, enter, and then I will say step over. So now we evaluate this state condition again. If it is true, we have to report the error again. If it is false, we can bypass the error message and then go on to the total accumulation. Let's see. If you go back to variables over here, x is now this time 4, right? You can see that's the only value that's been changed. So 4. So now if you go to expressions over here, you can see x is 4, and 4 larger than 0 will be true. Negation of true will be false, which means this particular expression over here will just be false. That means we're going to bypass everything over here, and it will go directly to line number 34. That's what we can anticipate. Let's see if that's really the case. And then you say step over. Yes, we go to line number 34. So what will we do over there? You can see the variables over here. At the moment, total is simply 5. Okay, from the previous accumulation for the first integer. And x is simply 4, the second integer. So we can accumulate 4 into 5. So if you say step over, you will see that total has become 9. So that's the total so far. And then I would be, at the moment, I is simply just 2. And then we're going to increment that at the end of the while loop. And then we'll say step over. You can see I has become 3 over here, right? 3. And now let's see, and then we after the end of the outer loop, we go back to checking the state condition again. So what do we have? If you go to expressions over here, you can see I is at the moment 3, and 3 less than or equal to 2 will give you false. So that means this condition over here, state condition, will be false. That means we're going to bypass everything as the body of the outer while loop. Okay, so now if you simply say step over, what should we expect to see? We should expect to see bypassing everything over here, and we'll go to line number 37 directly. Let's try that. If you say step over here, so that means go to line number 37 as we predicted. So now let's calculate the average. So what's the total here? If you move your mouse over, total is 9. Let's try the expression here. You can see that we have total over here is 9. And then what about total divided by 2.0, any expression you like, as long as the variables are in the correct scope. And then it's going to be 4.5 over here, right? You can see how fun the debugger really is. I really want you to practice on this. Okay, 4.5. So that means we can predict this particular expression on the right hand side as the assignment source is going to be 4.5. And 4.5 will be reassigned to average, right? So now if I say step over, you can see that, go back to variables, you can see average is now 4.5, right? And then we're going to say average is, as a printout, and then what's average? Well, if you move your mouse over, it's 4.5. If you say step over, you would say average is 4.5, right? So now you can see we did exactly what we did manually on the iPad over here. So now I really want you to really understand both versions. So now, when you're really running into trouble for your lab test or your lab exercises, you can definitely try to really trace the program by yourself, maybe on a piece of paper like how I did for the iPad. But if you really don't want the hassle of writing things down, your best friend will be Debugger. You can see how we did it, set a breakpoint to the first line of your code, and then that's how we did in line number 14. And then simply say step over one by one. You can definitely look at the variables to see what have been changed. And also you can look at the expressions over here, especially you can put the branching conditions or the state conditions over here in the expressions field and see if the branching condition or state condition should be evaluated to true or false, right? That's how we trace the code. Okay, so that's about using debugger. Let me just, before we end the tutorial video, please make sure you click on stop button here to terminate the debugger, and also you can switch back to the Java perspective by clicking on the top right, Java. Okay, so now what we have seen so far, we have seen the basic syntax for for loop, while loop. Also, we have learned about how to use breakpoints, debugger, especially in the debugging perspective. You can use the variables and also expressions panel to really see what's going on. Again, the very idea about debugger is like this. Since we have seen so many examples, it's really about this. When you simply got a fragment of code like this, you got a series of lines of code, you simply set a breakpoint somewhere in your code, and then you let your execution flow pause over there at the runtime, and then you can simply just step over, like what I have illustrated over and over, just step over one by one. For each line, you can simply compare the variables and also expression to see if everything is actually still within your expectation. As soon as you see anything that's outside your expectation, that's where the errors is for your code. Okay, so please practice the pattern over here, both on the paper and also on your computer.